Okay, hello guys. So today we'll be talking about a Leetcode problem which is called maximum number of words you can type. So this is a question in which we have a malfunctioning keyboard where some letter keys on the keyboard do not work, while all the other keys on the keyboard work properly. So if we're given a string which is called text of words that is separated by a single space, no leading or trailing space, and we have a string that is called broken letters, which has all the distinct letters that are broken on our keyboard. Our goal is to then return the number of words in text that we can fully type out using this key. So we have a couple of examples here, right, that we are given from this problem, right? So like example, we have text, which is hello world, and we have a couple of broken letters on our keyboard, which are A and D, right? So the output is 1. Then we have another example, which is text, which is Leetcode. We have broken letters, which is LNT. Obviously, from this, we can understand a bit, but I think we should break these examples down further so we can find the solution. So let's come over here. When you attempt a Leetcode problem, it is better to write it down and try to find a solution to it by breaking it down into steps. Right, so let's understand the problem. The problem is we have a string that we want to type out, right? Imagine it is hello world, right? But on my keyboard, there are broken letters that I can't type at all, right? My A and D letters on my keyboard do not work. So now I want to check if I can type this word out or not, right? So the first thing that we see is that we want to check each word and see if we can actually uh, type it, right? But these are two words together, right? Or and they're like a sentence, right? So the first thing I see that we need to do is we need to split these words into singular words, right? So we need to split hello into its own word, and we need to split world into its own. So there's a simple function on Python, right, that is called dot split, right? That lets you split on the basis of whatever you tell it to split. So in this problem, if we can see that the words are separated by a single space with no leading or trailing space. That tells me that because there's no leading or trailing spaces, we can split it based on the space between the characters, right? So based on the space between the characters, we can split it, right? So we'll use this function to split the words. Okay, so now that we've split the words into their own singular word, right? We need to check each character against the broken letter, right? Variables that we have A and D or whatever. What I would do is I would make broken letter into a set, right? Because when you search in a set, it's faster. So I would rather make broken letters into a set. So that'd be a second step. Then I would split each word into its own characters, check against broken letters. If the word does not have any of the broken letter sets, right, then I would add it to the counter. But if the word is part of the broken letter set, like world is over here, then I would raise a false flag and make sure it doesn't get added to the count variable, right? So now let's try to do this in code, right? So obviously we want our words from the text. The way we can do is we can split the text, right? We can split the text on the basis of the space that I told you. Split is, right? We can split the text based on the variable, right? On the space. So here's a space, right? Now we'll get hello and we'll get world, for example. Then what I said is we can take broken letters and we can make it into a set, right? So we can make it into a set, which is just faster to faster searching, right? So when we keep looking at it, when we keep iterating on it, we just want the set to be faster. That's why. The next thing we can do is we can initialize our counter, right? When we initialize our counter, we get that out of the way, and then we can work on the logic, the real logic. So now the real logic is that we have our words, but we need to check each word. So let's grab the word. How do you grab the word? You can say for word in words, right? Now I have the word. The word out of the words, we have the single word, right? And we can say that if it can be typed, right? If it can be typed, we want to raise a true flag, right? But what about if it can't be typed, right? We need to check, right? How do we check? Right now we have the word, right? From this for loop we get the word, right? From here we got our word, right? And now we're going to check that word. How do we check that word? Well, we can run a for loop in which we check for the character in word, right? Now we have the characters in word. If the character will is in broken letters, right? Then we want to automatically say that the B typed is false, right? Is false. So let's look back on this code. So what did we do? For words and words, we grabbed a word. Then we said if it can be typed, it's true. And now we're checking. So for characters in word, if the character is in broken letters, the B can it be typed is false, right? It's false. So can be typed is true. Let's call this can be typed, right? Can be typed, can be typed is false, right? Can be typed is false, right? Let's just name the variable what it is. Can be typed is true, can be typed is false, right? If it's false, we need to break out of this loop. So let's break out of this loop. And then we need another if condition. When you break out of the loop, we go back to the for and then we write a if condition. The next if condition is if it can be typed, right? If it can be typed, then what we want to do is we want to increase our count by 1, right? And then what we want to do is we want to return our count, right? Return the final count. So now let's run this code and let's check if all of our test cases pass. And let's see. And as you can see, all of our test cases has passed, right? It was expecting 1, we got 1, and it was expecting 2. Case 2 was expecting 1 1. Case 3 was expecting 0, and we got, right? So this is how you would run it. Let's submit it, right? And if we submit it, we would see that our runtime is 0 milliseconds, which beats 100% of everyone, right? Right? Because our solution is very uncomplicated, right? Some people use very complicated things that reduce the memory, right? But we just wanted to work on runtime, so we did the runtime. So I hope you enjoyed this video, and this will be a long series that shows my journey, and I hope you guys can learn from my videos as well. And yeah, let me know in the comments what are the Leetcode problems you guys are having difficulty with. I'll try to make a video on that as well. So thank you for watching. Please like and subscribe.